At this web address, I have some code here for C++. So there's a Word document with C++ code for the black model, 1976, and basically I'm following through the logic here of this particular problem. We're trying to work out the value of a caplet, which is an call option on an interest rate, and we're borrowing a sum of $10,000, and we're trying to cap at 8%, and this rate is quarterly and it's for 3 months. And then we're saying that the zero curve is flat. In other words, the, again, unlikely type situation, the term structure of interest rate is flat at 7%, and it's specifically quarterly compounding. And then we have the 1 year volatility for a 3-month rate is 20%. And then as a consequence, if the quarterly rate is 7%, that implies that the continuously compounded rate has got to be this 6.9395%. Okay, so we're trying to work out the value then of the caplet, and as we saw before, the value of that should then be using this formula here, 516. I'm going to set that up in C++. I have a segment of code which I will leave a link to beneath the video, and we have the same figures as identified in the question. We have this f equal to 7%, k equal to 8. The period of the option will expire after 1 year. The period of the loan is between T1 and T2, so the loan expires after 1.25 years or 1 year 3 months. As before, if this is the discrete rate f and it's flat with a flat term structure, then the continuous rate using this formula has got to be 6.9394, volatility 20%, and okay, here we're saying a floorlet. We can change that in the compiler in a moment, and the principal of the loan is 10,000. Okay, so we go into the compiler, and I'll just delete what I have here and paste from the Word document directly back in. We can beautify, so there's some indentation that may be useful, and okay, we can run our code and see what the output is. Now, again, if we go back to the question at hand, it was looking for a caplet, like the value of a caplet. So we were trying to determine the value of the caplet. This is our starting point here. Calculate the value of the caplet that caps 10,000. Okay, so we just execute the code, we run, and we get a value of the put as being 28. If it was a call option, we could change P to C and run again, and then we should get the familiar 516 like what we had before for the put. For the floorlet, 28. The value of the option itself, just purely using the black model without adjusting for the principal, would be this 0.002. But when we multiply by 10,000 and adjust for the period in question, we get, for the caplet, we get 516, which is consistent with before. So I'll leave a link here to this code, which can be retrieved afterwards. This you'll find below the video, and I will leave a link to a Word document also where you will have the web address as well and can download the code.